Hi viewers, welcome to Blue Dot Electronics. Here is the interesting circuit to make an automatic mobile charging, and it can be used for any other appliances. To make this circuit, there is no need for programming and no external batteries required, and no complex circuit is there. So let's get started. The circuit diagram and explanation link are given in the description below. For a list of components, kindly refer to the description. The second pin of the 555 timer IC to its sixth pin. Connect a 330 microfarad capacitor positive pin to second pin of the IC. Connect a 10 mega ohm resistor to the sixth pin of the 555 timer IC. Connect a 3.3 mega ohm resistor to the sixth pin of the IC. Connect a 10 kilo ohm resistor to third pin of the IC. Connect another end of the 10 kilo ohm resistor to base pin of the transistor BC548. Connect a 1 kilo ohm resistor to the collector pin of the transistor. Connect an IN4007 diode positive pin to the collector pin of the transistor. Connect 4th and 8th pin of the IC to VCC, but I left all the connections of VCC and ground so that I can connect in one shot at the end. Two IN4007 diode negative pins to be connected to the VCC. Connect the collector pin of the transistor to one of the coil pins of the 9V relay. Make proper holes on the 0 PCB to fit the relay. Connect an IN4007 diode positive pin to NO pin of the relay. Connect the positive pin of the 1000 microfarad capacitor to the common pin of the relay. Connect a positive pin of the buzzer to NC pin of the relay. A 470 microfarad capacitor positive pin to be connected to the VCC and negative pin to the ground. Take a center tapped 9V transformer and connect the 9V output wires to positive pins of the IN4007 diodes. Connect the neutral wire of the transformer to the ground. Connect other ends of the 10 mega ohm, 3.3 mega ohm resistors and VCC to an SPDT switch as shown. Connect the VCC and ground pins to the components as shown. Connect AC plug wires to the transformer and another common pin of the relay. Here I have used the MDF cardboards to enclose the circuit. Connect the push to on switch to another common pin of the relay and AC wire to an AC plug socket. Connect a transformer wire, AC plug socket wire and NO pin of the relay to another end of the push to on switch. Connect an LED across VCC and collector pin of the transistor via a 1 kΩ resistor. Now enclose the circuit using MDF cardboards and a glue gun. Now give the AC supply to the circuit and set the SPDT switch to 1 hour mode. Now press the push to on switch. Exactly after 1 hour, the circuit disconnects the main power supply from the mobile charger. For 20-minute mode, I am using the circuit to cook rice in an electric cooker. When you leave the rice cooker till warm mode, then there will be a problem of rice sticking at the bottom. To avoid this, we use a 20-minute timer mode for a perfect cook for 2 cups of rice without rice sticking. Now the biggest question is how the time is calculated in the circuit. It is by the formula T is equal to 1.1 into R into C. Here T is the time in seconds, R is the resistor value in ohms and C is the capacitor value in farads. For the 10 megohm resistor, the T value obtained is 3630 seconds or 60.5 minutes, and for 3.3 megohm resistor The t value obtained is 1197.9 seconds or 19.96 minutes. And yes, there will be an inaccuracy of less than 5 minutes when you use an electrolyte capacitor in the circuit. This is due to the leakage current in the capacitor. To get the exact time, use a tantalum type capacitor. Troubleshooting. Check the circuit connections with the help of a circuit diagram and a multimeter by setting it to the continuity mode. Check the polarity of the capacitors. Check the pin connections of the relay, as pinouts are different for different manufacturers. Check the 555 timer IC. Thanks for watching. If you like this video, then please do subscribe to this channel. Do share, like and comment. Thank you.